Swath acquisition has been getting attention across the scientific community ever since this groundbreaking LCMS technique became available. Assembled here for a roundtable discussion is a distinguished group of scientists to talk about swath acquisition, which essentially enables you to quantify virtually every detectable peptide in a complex sample in a single analysis using the TOF 5600 Plus from absciex. So let's talk swath acquisition. What does this all mean for analytical scientists who use LCMS?
I think the advantage of swath for us really is the ability to be able to see absolutely everything and to interrogate at different levels.
I think this is a technique that's really comprehensive. It's like building an encyclopedia.
Yeah.
We just keep on adding to it and making better and better spectras and getting better calls as we go through. I think this is, like Tony says, this is a fantastic way to have all that data and just keep on adding to it with all the knowledge that we have.
In our research, we encounter samples that are irreplaceable, and this is in the area of tumor biopsies. In cases where you only have that and analyze that sample once, possibly twice, being able to acquire all of the MS2 data is obviously a tremendous advantage. We'll probably be going back to those data sets for years to come.
It allows us to actually multiplex the quantitation of analytes. And I think that allows us to get larger, in our case, larger and larger quantitation of proteomes. So we can do beyond 100 proteins, maybe think about 1,000 proteins quantitating in a relatively routine LCMS assay. So I see that as being a huge potential. The other potential is that swath is giving us a map of the current state of that proteome.
I'm from Taiwan, and we are working on some national project for the drug discovery and drug target discovery and biomarker. So we are working on the personalized tumor proteomics. And in my experience, we have tried many different kind of tools, but we cannot find a solution to do accurate quantification for many proteins, especially with high sensitivity. So after we have this data from the swath, I'm so surprised that we can quantify so many different kind of membrane proteins or phosphorylated protein in one assay. So I personally believe that this may be the tool in the future in the clinical community because it's easy to use.
Given that it's the same experiment over and over again, its simplicity and the amount of data you can mine out of it is sort of mind-boggling.
Yeah, I can actually follow up on that because we've developed, since 2007, we've been developing like targeted MRM assays. We've been trying to make them larger and larger. But to develop these assays takes a good 6 months to a year to develop your targets, go from ID to picking your transition to doing that. And the nice thing about swath is you can basically cut the time down significantly, almost like a tenth of it, because you're just basically, you're getting your ID and quantitation together, and it's sort of, that's a real benefit.
Having the spectra being standardized across the system, across laboratories, across samples, it really gives us a capability now to really quantitate at a level that hasn't been done before.
So for me it's very interesting that swath is kind of in between shotgun and MRM, also just to put it very general. And we very often go, a typical experiment, you start to look for certain proteins, biomarkers or whatever, and then in the very downstream part you want to have a panel where you want to quantify across many samples, and in between there you would like to have a technology where you can look at many analytes but also in many samples, and for us that's really, swath is really the perfect technology for that.
I'd like to bring up the TOF technology, which enables the swath acquisition, and open it up to the table of what is it about the TOF technology that makes it interesting and relevant for your work?
You know, this new technology really enables someone who's collaborating in proteomics with biologists to probably for the first time produce interesting low abundance molecules and not limited by the very slow data-dependent acquisition schemes that we've used for the past 2 decades.
Spend more time on the biology rather than the technology.